Hey there kids, welcome to another math lesson. This is for Eureka Math Grade 5, Module 4, Lesson 10, homework. And it's a beast. I'm telling you, this is a terrible lesson. Terrible for children. Anyway, it's filled with information. Go watch the problem set video if you don't understand it. Maybe watch it again, even if you already were in class for the lesson, because it's got that much information in it. This is always tough for kids to understand how to set things up, where to put the parentheses, and to make the expressions that actually say what is intended in the problem. So it's pretty challenging. Let's get to it. The objective is at the bottom of the page. Compare and evaluate expressions with parentheses. So I'm going to talk about PEMDAS every now and then. PEMDAS is also mentioned in the problem set video, starting with parentheses and working in a specific order. Exponents we don't really use much of in 5th grade, but multiplication and division, remember, have more power, more strength, more importance than addition and subtraction when solving in expressions. So let's get into it. Write expressions to match the diagrams, then evaluate. Plus, they don't give us very much room to work here either. So look at the picture, figure out what they're trying to say. All right, this here is 1/4 of that. Don't solve this first. Write the expression. 1/4 of what? 17 plus 4. You should not have solved that, okay? You should write in parentheses what you're going to do. That's the first thing that kids do wrong. So 1/4 of 17 plus 4. Now, rewrite that in a mathematical expression with just the symbols and not the words. 1/4 of, now you can solve this, 21, like what is 17 plus 4? And so that's going to be 21 over 1 because this is a whole number. Now you can multiply across, like 1 times 21 if you had one line. And 4 times 1, remember that when we work with multiplying fractions, you do multiply across the bottom. Okay, that's another tripping hazard for students just coming out of adding and subtracting fractions for a month or two, trying to get common denominators. In multiplication and division, you don't have to worry about that anymore. But we do have to understand fractions as division. 21 divided by 4 is 5. Do your long division. Subtraction, put your fraction. Remainder in a fraction, and that's your answer. So this is equal to 5 1/4 right here, because I could repeat it. So 5, 10, 15, 20, and then 1/4, 1/4, 1/4, 1/4. That makes 1, so 21. So that adds up to that. So that's what we're doing here, is we're trying to make sense of it. This one, I don't know. I think it's harder. It looks harder. It is harder. So we have 2/4 or half of this missing amount. But the 2/4, the total, the sum is not given to us. So we need to get the sum of these, and then we have to double it. Okay, I'm going to write it up here because they don't really give us any room to work. So 4/7 plus 8/3. And I don't have a whole lot of time for coaching on these because there's so much to do. So if you write the expression first, now this is addition, not multiplication. I have to have a common denominator. And I have to do it first before I multiply. Forget about the times 2 for now. Get a common denominator of 21. Use the other number as your scale factor. Add these. 68 21st is what I now have to multiply by 2. There's no easy way to go about this. Just do the standard algorithm. 8 times 2 is 16. 12 and 1 is 13. That makes 136 on the top over 21. Now you have a division problem. And 21 is too big to go into 1 or 13, so we have to take it all the way over here to the ones place. Remember, round to 20. 20, 40, 60, 80, count up probably 6. 6 times 1 is 6. 6 times 2 is 12. That's as close as we can get without going over. And we have 10 left over out of 21. And believe it or not, that's your final answer. So what is the total up there? It's 6 and 10 21sts. Very strange. Okay. Circle the expression or expressions that give the same product as 6 times 3's. Explain how you know. I could take like 20 minutes on this. It's not this one, okay? Because we're not, 8 is not on the top. It's not being divided. This one could be 3/8. If I had parentheses, if I was going to put them in, I would make 3/8 times 6. Look, that's right over here like this one. Using the commutative property, you can change the order. Answer keys does not include that one. That's wrong. This is right. This is right. 6 times 3 over 8 or divided by 8, that's right. This is wrong. This is wrong. They are wrong because they're changing the 8. 8 should be the denominator or the divisor. Okay, so the order from top to bottom really matters. All the 3 that are circled, you've got to do the 3 times 6 needs to be on the top. 8 needs to be on the bottom. All of these show it that way. This one, again, not in the answer key. So teachers, if you're watching this one's not included, but it's right by everything that they've taught us. So I think we're right, and I think the answer key is wrong. All right, next one. Write an expression to match and then evaluate. Okay. Straighten out so we can get into this one. 1/8 the sum of 23 and 17. So we have to add here, and it's going to be 1/8 of the sum of these two numbers. Sum is addition. 1/8 times that. So first add 7 and 3 is 10. Carry 2, 3, 4. So it's 1/8 of 40. Now that's a little bit easier, thank goodness. And you can cross cancel. Remember how to move that around if you did 1 times 40 over 8 times 1, and then you just go, how about move the 8 over here? 8 times 1 is 8, move it over here. 40 divided by 8 is 5, therefore the answer is 5. Next one, subtract 4 from this, 1/6 of 42. Put that in your parentheses. It has to be done first, then subtract 4 from it. You cannot have the 4 out here. That is not correct. 6, fortunately, is a factor of 42. So if you were to multiply these out and get 42/6, then you would have 7 minus 4. There's your answer there. 7 times as much as the sum of this and this. The sum of this and this. 1/3 and 4/5. So again, when adding, there's no easy way around it. We have to get a common denominator. 15 will be it. The other number is your factor to scale. Add those. We'll take care of the 7 next. 17/15 times 7. And from here, there's, we could, why change it to a mixed number? I would not change it to a mixed number. I would just do my standard algorithm. 17 times 7, 49, 9 to 7, 11, 119 over 15, and then do your standard algorithm for division. No room. No room at the end. 11 is not divisible, so you have to take it all the way out to the ones place. And we're getting about 7, 5, 35, 9, 10, 4 and 1, which leaves us with 7 and 14/15. That's for this one. There is no place to do work here. Okay, next one. 2/3 of the product of 3/8 and 16. So it's 2/3 of. That means multiply. The product means I also have to multiply in here. 3/8 and 16. When multiplying, cross cancel. Cross cancel. If I was to move this over, it'd be 16/8. I get 2. When you multiply here, you get 6. It's 2/3 of 6. So cross cancel again. Move the 3 over. And when you do that, you get 4. I can't believe how long this is taking. Okay, 7 copies. Remember that word, and I said it's only in Eureka Math. It's really kind of strange, but copies, like the copier. 7 copies of the sum of 8/5 word form and 4. Now this is a whole number, so if you would like to not worry about the denominators here, change this into a mixed number so that you can kind of simplify it. 5 into 8 one time with 3 left over. And then you can combine this and you don't have to have any problems there. So it's 7 times 5 and 3/5. And then we can take this and make it an improper fraction and multiply the whole thing by itself, or you could do 7 times 5 in one step and then 7 times 3/5 in another step. Let's just wrap it all up and do one step here. 7 times 28/5. Now this is 7 over 1, so it's 28 times 7. And we get 196 over 5, and then standard algorithm. 3, 15, 4, 6, 9, 45, 1, and there we go. And if you got 39 and 1/5, you are all set for that one. And finally on the front, 15 times as much as 1/5 of 12. Just put that in a fraction over 1 so that you can be ready to work with it. It's going to be 12/5. When you can, shift over, use the commutative property. So this would be 3, and it's 3 times 12 for 36. Do you see what I mean? This is terrible. This is just mean. I'm sorry. It's like one of the most horrible lessons. It's difficult, and it's lots of work and thinking, and I hope you guys are hanging in there. Okay. Use less than, greater than, or equal to make true number sentences without calculating. Very important to be able to explain. So let's take a look at the numbers. If I see 2/3 on both sides, it's like they just offset each other. You can kind of ignore it. So then all that's left is 12 plus 9 over here. That's going to be a lot more than 15. So wha-bam. 2/3 is equal on both sides. And 9 plus 12 is greater than 15. There, you can do it in numbers and symbols, and it doesn't take as much writing. Let's look at the next one. 3 times 5/4 times 3/5. 3 times 5/4 times 3/8. All right, again, this is the same on both sides. Eliminate it. Now we're only comparing 3/5 to 3/8. Which one's bigger? 3/5. This is more than half. Remember, find where the half is, and and understand, like, this is less than half. What's half? It's 4/8. So this is less. What's half? It's 2.5. So this is greater. So eliminate 3 times 5/4. Same on both sides. Then only compare the fractions. Okay, and so that's where we've got 3/5 is greater than 3/8. So we're really just looking at those. Then finally for the last one. Okay. 6 times 2 plus 32/16. Think about what that's equal to. While you don't have to solve it, we're not calculating, we're just thinking about it. And 6 times 2 plus the same value. So thinking about what this is equal to, which is 2. Okay. If I've got 2 plus 2, okay, I'm trying not to calculate. I'm trying so hard not to calculate. I've got 2 plus 2. So I've got my 4. If I have 6 times a number as opposed to 6 times 2, which is smaller in itself, plus 2, then my bigger multiplication, okay, is going to give me more than adding. That's as clear as mud. So if I end up with 6 times 4, okay, I'm going to try not to calculate. I almost can't even do it without calculating. And I have 12 here plus 2. I can stop here and just say the product is greater than the sum. Okay, and I really can't explain it in a good way without at least getting this part that is, equal on both sides. I have to, I don't know. I'm not a math genius. I guess that's where I'm going to stop. So, all right, last few questions about Fantine and her flour. Fantine bought flour for her bakery each month and recorded the amount in the table to the right. For A through C, write an expression that records the calculation described, then solve to find the missing data in the table. So we need to find the amount of flour for April, June, and August. That's we're going to use some comparison statements. So let's use the data in the table. She bought 3/4 of January's total in August. So we're going to try to find this one. But we need 3/4 of January's total. 3/4 of 3. Hopefully you got that. Go ahead and solve. Yes, we can. If you need to write it out, go ahead, but 4 fits into 9 2 times with 1 left over. Write that in here. And let's move on. She bought 7/8 as much in April as she did in October and July combined. So we're trying to figure out April, but it's 7/8 as much. Now, don't let this stop you. This is what we're solving for. We're trying to figure out October and July combined. October and July combined. Thankfully, we have a common denominator. So when you have your 1 plus 3/4 and 1/4, that makes 4/4. So 1 plus 1 is 2. So that ends up with 2. Now we're multiplying, and you haven't probably seen where we're going to do the reverse of the shifting. But if I was to shift these back and forth so that it was then 7/1, so it's really 7 times 1/4 because I can simplify this. So it's 7 times 1/4 or 7/4, which is 1 3/4. And that is our April total. Okay. Now how about C? Oh, there go the lights, because of course this is taking so long. All right, in June, we're trying to solve for June, so we'll go back and forth. In June, she bought 1/8 pound less than 3 times as much as she bought in May. Using your chart for May, go back, it's 9/8. Okay, and it's 1/8 pound less than that. So you have to get the answer to that before you can take the 1/8 pound away. And start by setting this up with your, I've got to solve in parentheses first. So 3 times 9 over 8. Is there any way you can simplify? And sometimes there is just not. Ooh, I almost put my 7. 27 over 8 is what I would like to have first, and then I can subtract my 1/8. Since I have this nice little fraction here, I'm going to use it. I'm not going to straighten it out into a mixed number. They already have common denominator, so that would be 26/8. And now that I'm finished with my calculation, I can straighten it out. 8 fits into 26. 3 whole times with 2 left over. Simplify to 3 1/4. Now that is for June. Fill it in. And as if all that wasn't enough, now they want you to take the data from the table and display it in a line plot, because at this point, torturing people is just fun for them. Line plots from lesson 1. How do you make a line plot? First of all, you have to look at your data. You want to start with 0 usually if you have numbers that are close to 0, which we do. We have something less than 1. So we're going to have, but they're all positive. So we have 0 to what is the biggest number? We have fractions. We have a whole number up to 3, and we have something greater than 3. So we have to go up to 4 with our line plot. So 0, 1, 2, 3, 4. And how many fractional units should you divide your line plot into? So you have to start looking at the denominators, because that will tell you how many pieces you need. Most of them are fourths, but this one here, 9/8, that's going to turn into 1 1/8. And since we have to have eighths for one of them, it's nice when you have consistent measurements for all. So start dividing everything into little halves, and then take all your fourths and divide those in half. And if you make your lines like a little bit longer, shorter, it can help you kind of find your way. You don't actually have to do the whole thing in eighths, but it's really helpful if you do the one between 1 and 2 into eighths. So now display the data, and this would be pounds of flour. Okay, so you're just going to put the X's where they belong. So it's really not that bad once you make this. We're going to put an X over 3 because that's one of our numbers. Just go down the chart. We have 1 at 2. We have 1 at 1 1/4. Okay, so remember, watch out. You have eighths here. So where are the fourths? It's here, here, and here. So 1 1/4 is the second number. If you wanted to convert that to eighths, how do you get from 4 to 8? Times 2. And so therefore do the same on the top. That's how you know it's 1 2/8. The next one is 1 3/4. 1, 2, 3. 1 1/8. There's that one on that eighth mark. Everything else is on fourths. 3 1/4. Remember, this is the eighth, so it's going to be right here. It's going to be 2/8 are equal to 1/4. Then 1 1/4 for July. That's your second X in that spot. 2 1/4 is up there. 11/4. Again, go back to your chart and straighten it out so that it's a whole number. 4 fits into that. 2 3/4 times 2 3/4 using the fourths. 1, 2, 3, not the eighths. And the last one is less than 1. It's at 3/4. So your line plot should look like this. It should be pretty well spread out, 1x over all these different numbers, but this 1 1/4 or the second tick mark should have 2. That's how you know that's correct. And finally, how many pounds of flour did Fantine buy from January to October? Not even kidding you. You have to add everything up. Just because it's like the icing on the cake. Add everything from January to October. You can use all your fourths and convert at the end into eighths. That will work for just that one, or like leave it out. Plus 1 3/4. Write them all out. That's right. You can do plus 1 1/8. Use the converted amount. Use 3 1/4. 1 1/4. I'm on July. The next one is 2 1/4. Then 2 3/4. And then 3/4. There's no easy way to go about it. Just take it apart. Do whatever works for you. I'm going to do all the fourths. I will skip this one for now, and I will rewrite it, and I'll do all the whole numbers. So 3, 4, 5, 6, 7, skip it, 8, 9, 10, 11, 12, 13, 14, 15, plus all the fractional units. Even if I end up with an improper fraction, that's okay. So everything is going to be over 4. I'm going to use all my fourths. So 1 plus 3 is 4. Skip it. 5, 6, 7, 8, 9, 10, 11, 12, 13. Don't worry about straightening it out, but do rewrite. So we added all the whole numbers, hopefully. Added all the whole numbers. You can straighten this out into a mixed number so that we have our whole number to add. And then we can also add this one too. So 13/4, it would be 3 because of 12 and 1/4, and then plus 1 1/8. And now we have a lot simpler problem. Sorry, I have to keep flipping back and forth. We have 15, 16, 17, 18, 19. And then we have the 1/4 and the 1/8. Here's where we're going to get a common denominator. I'm going to change the fourths to eighths. Leave this one alone. 4 times 2. So therefore, 19 3/8. And I am so glad I got that right answer. Woo! Okay, because that could have gone bad in a number of ways. Anyway, that is the total amount of the pounds of flour. Yay. Click subscribe and come back again. Maybe we'll survive another math lesson together. See you on the next one. Bye for now.